Okay, today I'm gonna simulate a algorithm called CP mesh or optimization method called CP mesh, and it looks like this. So this is a paper that introduces the CP mesh and how to implement it in mathematical way. And here's the explanation of CP mesh. A CP mesh is a triangle mesh whose circles form a packing. Then circles, which arc center the mesh vertices and are orthogonal to the instant of the neighboring triangles, form a packing too. So basically it looks like these used a lot in architectural field nowadays. And here is some equations how to simulate this or how to achieve this CP mesh using mathematical way. So basically if you have this kind of irregular triangles, and if you use this algorithm, you'll be able to get a clean mesh looks like this. And this is called CP mesh. So I would like to implement this using Houdini based on these method that explains here, but I'm not gonna like use the exact equation like these since I'm really not from the mathematical field, so I'm kind of guessing what it means and try to do it in more understandable way, geometrical way, mostly using vector operations. So start. First of all, I need to make some base mesh to optimize, which has a triangle faces but in regular way. So let's do that first. What I want to make here is some random mesh, so I want to use a metable. So let's make a geometry first. Delete this and let's make a metable. One metable first. And let's view the shading to, let's set the shading to smooth wireframe, wire shaded. And just one metable is not that interesting, so I'm gonna make 3 balls and connect it together. So I'll make an add component to add 3 points, and I'll let them able to modify it and move this point somewhere randomly. Yeah, something like this. And let's use a copy stamp node to copy this metable onto those points. And looks like this. And I can move a point to have a better shape. And let's set the size to radius to 10, 10, 10. And then I have to move the points, all the points, a little bit bigger, a little bit farther. Like these, like these, these. Yeah, somewhere around here, I guess. Could be any kind of shape. So if you think you're ready, next I have to convert this into a polygon. So let's convert this to polygon using convert node and to polygon, and I can change here to set the quality, the resolution of the polygon. So let's say around 3. Yeah, looks smooth enough. And since right now this is quadrilaterals, means it's has square divisions, somewhere it's triangle as well, but I want to make all the faces to be triangle, so I use divide component, the node, to divide quad face to triangle face. Now this is okay. Now this will be the base mesh to calculate, optimize for CP mesh. So let's name this original mesh. Okay, after this, the first thing I want to do is to give each point for the mesh to have its normal vectors. Right now I don't think it has it. Yeah, it doesn't have it, so let's give a normal node and give each point a normals, like this. Yep. And next, first of all, I want to see how the inner circles for each triangle looks like right now. So first I want to draw the circle inside the triangle. So I need to give a wrangle, I think. Let's give a primitive wrangle, since I want to go through each triangle faces, and connect it to here. And let's name it calculate center. And let's begin writing. Now, first of all, let's get the point number for each triangles. So let's name it PS, and I can use putting points for each primitives. Yep. And let's go through all the points in each primitives. And pick up each point position by accessing it. Okay, copy this 2 more and 2, 3, and like this. Okay, then I also need to know the length of the opposite side of the edge for each point, which is length of between P3 and P2. PT3 and PT2. And let's have a variable called edge length. And append each length that I calculated. And now let's first, this is okay for now. Oh, and I think I need to have two more informations. One is total length. This is the total length for 3 edges of each triangle, and total vec is a position is a vector to the position of point 1, the total addition of vectors from center 0, 0, 0 to point 1 for each point. Okay, put 0, 0, 0 as initial value. Total length, total vec. Give something like this. Now here's the calculation part. Now I came to this Wikipedia page in circles and X circles of the triangle, and it shows some equations to get the center point, how to get the center point of the inner circle of the triangles. So I use this equations to calculate where the center point is. Now, in order to do that, first I need to get the area of the triangle, and it's also written in the Wikipedia, and it's like this. Root edge length it's gonna be a long script. Gotta expand this thing. Edge length 0 minus edge length 1 plus edge length 2 times edge length 1 minus edge length 2 plus edge length 0 times edge length 2 minus edge length 0 plus edge length 1. Okay, I don't get any errors. Next is the radius of the circle is calculated like 2 times multiplied by area divided by edge length 0 plus edge length 1 plus edge length 2. And the vector, give a vector, and the center point will be total vec divided by total length. And give the primitive attributes, the center to be sen, and the radius to radius. Apply. And let's see if I got it. To primitives. So I get this center position for each triangle and the radius. Oops, I misspelled it. Radius. Okay. Now I calculated the center and the radius of the circle. Let's normalize. Let's give a normal for each triangles. This one gives a point, normal for points, and this one I want to give it for primitives. Now, so I have triangles in each primitives in total of around 3,000 right now in primitive areas. And since I just want to drill circles right now, I want to transfer those primitive info, which is center and radius, to points. So I'm gonna give a primitive wrangle, and I'm not gonna connect this to the first one but to the second one, and set the round over to detail only once, and I'm gonna start writing here to transfer the primitive info to point. Not sure if it's the right way to do it, but it works, I think. Now first I want to get the total number of primitives inside a primitive area. So I can get that using n primitives function from the output one, and for each primitives get the position of the center point using prim, and add a new point. to this position. And I have the radius from the primitive. And I also have a normal vector from the primitive, which I just made. And I want to transfer these attributes to point to that I just made. So set point attrib and first radius to pt and set point attrib to n pt normal. And if I click apply, okay, I got an error. Okay, I'm missing an equal. Okay, let's see if I get it. So I have points. Ooh, looks wrong. Yeah, looks totally wrong. So I get the radius and the normals, but the position looks totally wrong. It's because x and y and z are all the same somehow. Okay, must have mistaken here. Let's go back and see. I must have missed it somewhere around here, I bet. Now let's go look from above. Prim points. Wait. So I'm setting to primitive wrangles. This is okay. Making a new array called edge length. Total length is equal 0, total vec 0, 0, 0. And for each point, get a point like this, like this, like this. Getting the length, edge length. Now this looks okay. So this should be here, I guess. Wait, before doing that, let's check if the total vec is correct at this point. Okay, it's wrong. It's totally wrong. Huh. Yeah, it's totally wrong. Okay. So, why is that? Let's see. I have to, I set it to float, but it's supposed to be vector. That's why. Okay, now I seem to get the point here. Yep, I'm getting the points on the middle and the center of the triangle, which should be a center of a circle. Okay. Now let's go back here. Have the points and radius. Now let's continue. And let's name this prim to point. And let's give a single circle and copy this to each point. Since each point already has a normal, it should align to its normal. Oh. I want to give copy stamp. It's pretty big. Let's give the circle a small size. This. No, right now it's not attaching to triangle since each radius is the same. So I have to transfer this radius parameter inside a point attribute to the radius of the circle. Now in order to do that, I'm gonna use a for each loop. Give this for each, and let's make a null and name this each, inner each. And here I'll give a transform to scale up each circles. Now in order to do the scale, I want to make the radius to 1 so that I just have to scale by this radius value. Now I also have to set the for each loop to go through without the piece name. And let's go to transform. First I need to set the pivot, and this will be the center of the circle. So I have to access to each point, which is this point position. So let's get to it. For expression function, there is a point, and for inner circle, inner each, and 0, and I want to access to the P, and X is the index 0. Now I'm not getting any numbers here. I don't think I need semicolon. Okay, I got the number here, so same as this, use it for Y and Z. Okay, now I got the pivot. The things I have to do next is to scale. Control the scale based on its radius. Now I can also access to point attributes. And name is radius. Which gives me 0. It's because I don't have the radius in attributes. The reason is because in the copy I not transferring this radius when copying the circles into each point, so I have to transfer attributes, use this. Now I get the points. Since I have the radius here, transfer to the scale. Now I have each circles that's inside the triangle. Now I can see the triangle's edge by doing this. Yeah. So this is what I get. This is what I'm getting right now from this mesh. And to make it easy to see, let's color this something like red. And you can also see the back of this mesh, so also let's merge this circle with the original mesh. Somewhere after calculated the center. Now network wires already seems to annoy me a little bit, so I'm gonna type Shift S to make it like a round wire. Looks more organized to me. Now, next, if I see this, the circle is kind of hidden behind the mesh, so I want to somehow offset the mesh a little bit to inside. In order to do that, let's calculate the normal again for each point. And let's make a point attribute, point wrangle. And for each point, let's offset inside using a normal vector. So first I want to get the normal vector. Yup, and normal. Let's normalize the normal. I think it's already normalized, but just in case. And also let's get the position of each point. Like this. Yup. And let's calculate the new position, which will be position plus or minus normal vector, and the length will be 1, should be fine I think, and set point attribute and change the point position for each point to its new position. I guess the offset was a bit too big. Yeah. Let's well, multiply this by 0.1. Yeah, looks okay. Okay. Could it be 0.05? Still okay. Okay, let's go with this. So now I have these as a checking function so that I can see if the circle is connected together. Circle is packed together. Right now, obviously, it's not packed at all. Okay. The thing I'm gonna do next is the main part, the optimization part, to get the CP mesh. Now let's group this together. Group this together. And first let's make a controller to give a parameter. This time I don't have much parameter to control with, but I'll just give one big parameter, which will be a optimization speed, so that you can control how fast does the mesh will be optimized. And let's color this something like blue so that I can see it clearly that it's important. Now here in between, I'm gonna have to iterate the mesh over and over again for each frame to optimize its point position so that it will give a CP mesh, a circle packed mesh. Now, so I need to give a solver in between here, and let's go inside here. Now, the first thing I need to do is that, let's go back to the top end. I realize if I look at the paper that explains how to implement the sphere CP mesh, you see that first you need to get the pair of meshes adjacent to its edge. So 2 mesh in a pair is what I need to get first. So I need to do some wrangle stuff to get that. So before going into the solver, I need to get that information. And to do that, I need to give another wrangle somewhere somewhere between somewhere before solver, I think. And let's name this, let's get the primitive wrangle, but doesn't have to be primitive. Change the run over to the detail, and let's name this set info. Connect this to the normalized primitive, and this is gonna be an important part. Now first, And the thing I have to be careful is that if I connect to the first input, it will give the output gives a same number of points or primitives. So I don't want that. I want to start from the blank. So I don't want to connect to the first input. I connect to the second one, so that initial output it gives 0 value to any of the point vertices or primitive area. So from here, let's go to the editor, and first I want to get the number of points from the input 1, and I'll give a registered hedges. Hedge means half edges. And give a point indexes array, new array. And first of all, go through each point from the input and give array which I just made the index number. And next, let's start from the last index of point. It's because I'm gonna remove it afterwards inside a for loop, and increment by -1. No, let's get the point index first, like this, and let's get the neighbors of each point. Neighbors will give you the neighbor points in the mesh network. And for each neighbors, let's first apply to see if I got any errors. No, okay, let's continue. So the neighbor index will be neighbors and let's get a half edge for each between points and neighbor point, and I can get that using point hedge function pt. Now each edge has 2 half edges, so I have to write 2 times. This, and from these half edge I can get a primitive using hedge prim. Okay. And let's make a new vector, call new point position, which will be a point position for the pair of primitives, or pair of triangles adjacent to one edge. Could be anything actually. It doesn't have to be calculated, but I'll just make it like a center point of the edge. Although I'm not going to use this later on. And make. There's no boolean, I think, inside Houdini in Vex, so I'm gonna use integer. So if the make new is 1, let's make this pair, but if 0, don't make it. And use first, go through each registered hedges. And get the registered hash index. And if hedge 1 equal to registered hedge, or hedge 2 equals to registered hedge, which means I already made it before. Make new, set to make new 2 minus 1. No, I mean 0. Oh, got an error. Okay. Undefined variable pt_pos, which is here. And pt_pos, I think I forgot to make this. Yeah, I have to get the position of each point. Name pt_pos coin. Like this. And I still get an error. Undefined variable neighbor pos. And of course I'm missing this as well. Equal point at the neighbor index. What I'm afraid of the Vex is that I might make a spell mistakes and it still runs without errors, so it's hard to debug. Okay. Now after this, if make new is 1, then let's go make some new pairs. And if prim1 is not -1 and prim2 is also not -1, then int new pt equals add point to yourself new pt position, and since I have just used the edge, let's add a hedge 1, could be hedge 2 as well, but either one is fine. So I'll add to the registered edges edge 1. Okay, and make a array of prims set, which will be 2 primitive arrays, prim with prim1 and prim2. Also, let's give a edge points, which will be the start point of the edge and the end point of the edge, as point and neighbor. Okay, so last of all, set point attribute to set this variable I just made to an attribute called primset to new pt set point attribute to edge pts to new pt position and prim edge pts. Okay. Now this should be good. Apply. And let's see. Nothing. I get nothing. Okay. Must be missing something. Let's see. So first of all, it's set to detail only once. And let's see if I'm getting this value. But I cannot do that. I have to. So it seems this is not called somehow. And why is that? Let me add one example point. Add point to yourself. To 0, 0, 0. Okay, I get the point. And so this is okay. Now, let's see. Add, wait. Set point attribute to yourself to point to some sample attribute to example point yes. Okay, I get this. And How's this? Length of PTS. Yeah, I still get this. If I set it here, then let's just give I. It's hard to tell. I minus 1. Yeah, I get this. So inside a for loop, n equal minus 1. Yeah, I still get it. So it is getting a neighbors for sure. Now inside the neighbors, I get the neighbors. Yeah. I'm getting the neighbors, point position. It's not. And neighbor position equals 0.1 p neighbor, which should also be fine, I think. Yep. And how's this? Point hedge. Hedge 1. Do I get it? Yup. Hedge 2. Do I get it? Yup. Yes. How about this? Prim 1. Yes. Prim 2. Oh, nope. But it depends. Sometimes it gives minus 1. So it doesn't always have to be. But here I have to. Okay. Now I know the reason. And now, yes. So these are the maximum. This is the total number of pairs. Like, for example, this here triangle and this here triangle is one pair. This here triangle and this here triangle is one pair. This triangle and this triangle is one pair. And it's all here with the index of primitives and the starting point and the end point of the adjacent edge. Okay. Now I got all the information I need. Let's get back and give this set information to the second input of solver. That's right. And also I want to connect one more information into the solver, which is an original mesh. Yeah, here. Original mesh to the third one. In order to, well, I'm gonna use the original mesh to project the iterated point onto the original mesh so that it won't go outside the mesh. It always stick to the mesh, the original mesh. Well, I can just use the first input, but I'm putting into the third input since sometimes I want to reduce the point, reduce the triangle number using reduce node, something like this. So I want to always put the third input the high resolution geometry. Now let's go get into the solver finally, and let's do some fun stuff. The main part. Now, first let's rename some inputs. So this is the second input, which is the set information, and this is the third one. This is the original mesh, and first one and fourth one I don't use it, so I'll move it somewhere. And let's start. Now it's gonna be really vex heavy stuff, since I want to calculate how to move each point on the mesh to optimize it for CP mesh. So I'm gonna first give a point wrangle and look into each set, primitive set, which is inside the point part, not on the primitive part. Why do I have these? Because I made a debugging value before. Gotta get rid of that. Okay. And let's name this optimization. Yeah. And also I want to connect the original mesh. No, I mean not the original mesh, but the first input one, which I want to iterate for each frame, with each frame, to the second node, the second input. And let's get writing. Now, first I wanna get the valuable attributes, get the variable of the primitive sets, which is inside attributes of each point. Call prim set. Was it? Okay, I'm not getting a prim set here. Maybe I'm missing something. Let's go back. And okay, I do have here. And if I input it here, oh wait, this, yeah, I have here. So it's okay. And the name is prim set. Prim sets, S with a capital letter. Okay, and then for each number, and make a new array called indexes vector vex and first I want to get the point list for triangle A. Triangle A means if I have a pair of primitives like two triangles, this will be triangle A and this will be triangle B. And you can get this by using prim points for prim set 0 and PTSP prim points prim set 1. Next, I want to have a half length. Doesn't mean it's the half size of the edge. It means it's from the point position to the tangent point of the inner circle, which I named it half length here. So if I have the circle here, if this is the tangent point of the circle, where the circle attaches its edge, this will be the point that calculates the distance from the starting point to make a half edge. So if half length A means that if this is the triangle A, this from the starting point to the half edge for this triangle is this one. I don't think that makes sense. It doesn't make sense, but it's okay. I guess you'll know it later. And also you need for B as well. Here for here. And for each points in triangle A, let's get a PT1 point PTS1, and this is similar to what I wrote before. The only thing I need to be careful is to not mistype, since it's gonna be a lot of coding here. You might not like it. Okay, and I can calculate the half lengths. It's also written in the Wikipedia I showed you last time by an equation like this. Okay, this should be it, and append the lengths to half lengths 8. Okay. And do I get an error? Yes, I do. Where's that? Seem I'm missing the bracket somewhere. And where is that? Oh. Let's comment this out. Still get an error. Okay. Unexpected curly bracket. Why am I using it? Oh, it's okay. Sometimes it happens inside a solver. Okay. But this one, I am having an error. And where's it? Oh yeah. Here I miss the bracket. I mean wait. Yeah. I'm missing all the brackets here. That's what I thought. And still. Undefined variable half length. And because I misspelled it. Okay. Now I want to do the same thing for PTSB. I'll just copy this and name it B and B and B and B and B and B and to the half length B. Apply. Okay. Gotta make sure I wrote it correctly. Okay, let's go. Now let's get the starting point of the adjacent edge and the end point of that adjacent edge, which is ST point edge PTS, where I stored all the points for starting point and the end point of the edge for each number. The index 0 will be the starting point, and endpoint will be the index 1. And now I wanna so since I have this ST and ED, I wanna know the real index of the point in the original mesh. So I have to go through all the points inside the original mesh, I think. And no, I mean, this has already got the points. But what I want to do now is that since I already made get 3 points for each primitives, for each triangles, for triangle A and triangle B, and you have 3 indexes, and you want to know like which of the three is related to the starting point and the end point. That's what I want to look for. So let's make available start A, start index -1, and also I want to know as the other index, which is, if you have starting point and the end point, the other point will be this one. So this is the third point, which is not end starting point nor end point. You want to get those two indexes. And we'll go through each PTSA. PT1 equal PTSA I, and if PT1 equal ST, then starting index is I. If PT1 is not ST and PT1 is not and as well, then S, the other index, will be I. Okay, save this and continue. And I want to do the same thing for a B. So let's copy the A part, paste it, and rename A to B. It's a little bit tedious, but it's the only one I could think of. Yeah, there must be a more clever way or smart way to do this, but I couldn't think of it, so I'm doing this way. Now I have the starting point, starting index for each. What I want to do next is get the end point. Now this is really tedious, I know. So rename this to A and index and other index. And look for PTSA is okay. This is okay, and this should be ET. And this should be ED. Should be ED. This is okay, actually. ED. Yep. Okay. Should be fine. And let's just copy this again and do for the B again. PTSB, B80 index, B80 index, and apply. And I get no errors, but I might have somewhere wrong. I have to change this to ED. Yeah, and because I typed it ET. Okay. Now this is okay. Now let's get a half length from starting point of triangle A and starting point of triangle B and end point of triangle A and an end point of triangle P by, let's name this starting point length from the half length A array that I made before using starting point index, which I have just made, and do the same for B starting point, A starting point in the end point length. Yep, and now I want to get the point index for each position in each triangle A and B. So A starting point is B starting point is, now I'm getting tired typing, int A st other pt equal int b st st other pt equal pts b st other index, and let's copy this again, paste this, and rename this to ed 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 ed. Okay, now I can get the speed parameter I set before from the controller object here. Let's name it scale, and from an object node, object network, geometry 1, name the controller. The name of the parameter was optimization speed. Okay. Now, also, let's get the edge length, distance between the starting position of the edge and end position of the edge. And this is because I don't have this and this. So starting point of the edge is pt pause point a starting point in vector ed pin point position equal point 1. Well, this could be a underscore and or b underscore end point. Either way is fine, should be the same. And now I get the edge length, and also this is the important part. make a variable called different lengths, and calculated by absolute power of 2 of absolute value of st lengths minus b st lengths divided by edge lengths. Now this value, I mean exactly this value, absolute a st length and b st length. This is the half edge of the triangle A and triangle B for starting point of the edge, and the most optimized mesh is that this value will be 0. So what I have to do is to try to make this small as possible, which makes a CP mesh. You can see that from this diagram in the paper. So consider this is a triangle A and this is triangle B. And the variable I just made, a underscore st length, is from this point to t13, the length of b1, between b1 and t13. And the b underscore starting length is the distance between v1 between v1 and t13, but for this circle, this inner circle, the first one is for the inner circle for triangle A and the second one is for the triangle B. And normally before doing the optimization, there is a gap between the tangent point of the inner circle A and an inner circle B. So if it comes to 0, if the distance is 0, then it's connected. Circle is packed. That's what I want to make. That's what I want to achieve. So I have to give this kind of a measured number. Now, if the half length of triangle A is smaller than B st length, then I want to set the scale to minus. Else, don't change. I don't have to write this, but just to be clear. Okay, now the operation I'm gonna do now in order to optimize the geometry is that if so I have this starting point and the end point of adjacent edge. Now if the tangent point of each inner circle is offsetted, I somehow want to rotate this edge, adjacent edge, somewhere this way or this way, so that at some point this circle will meet together at the tangent point. So the rotation is the key to optimize here. Now let's try to make that, and still a lot of coding. Sad to know. Now first I wanna give it an angle how much it should rotate, and it should be derived from the different lengths which I made. So if the lengths between the tangent points is bigger, then the rotation should be bigger as well, so that it will optimize faster if the offset is big. So the angle is calculated using different lengths times scale if it's going to the other direction or the positive direction. And just to make it human readable, which I don't really care actually, multiply by pi and divide it by 180 so that this value will be a degrees. I mean not degrees, I mean radians. This value is degrees, and by using this I can convert it into the radians. I think I need to use radians in order to rotate the vector. Now next I need to set the center point for the rotation. So I name it center pos, and calculate it like this. And get the end edge position. Minus 0.1 starting point. And doesn't have to be middle of the edge, but I want to make it the middle of each tangent points, which kind of makes sense to me. Tangent point of inner circle, I mean. This might not make sense to you at first, but if you draw it on paper, you might get it afterwards. For now, I'm not gonna explain that much, and I get an error. Okay. Where is that? Is here? Nope. It's here? No. So the undefined value will be st length. Okay. Somewhere, okay. Gotta be capitalized. Okay. And in order to rotate the vector, I'm gonna have to make a matrix starting from ident, and vector, and I also have to make an axis for rotation, which could be a normal of the point. And rotate. For doing that, in order to use the normal of each point, I think I already did it beforehand, but let's make sure to make a normal for each point every frame. And I have an axis. Let's rotate the vector for a vector on the end point of the edge first. I'll do the starting point afterward. It's okay, yes. And I just rotated the matrix. Now I have to use this in order to rotate the vector. First I need to make a vector to rotate. Point 1 P E D P T point 1 P S T point times edge length starting length plus starting length. And let's rotate this, rotate. Using the matrix I made, and the new position for the end point will be center point equal vec to rotate and last of all I need to get an offset vector, which is a position difference between new position to the original end position. Okay, and let's append this to the vex, the offset vec to the vec, and append the index of the endpoint, the indexes, and as always, undefined variable send pos. Okay, send pos, not send pos. Okay. Now I have the end rotated value. Next one, I need to give a start point, as always. Now let's rename ED to ST. Hopefully that's all I need to do. For this one, this should be okay. Yeah, I think so. And wow, it's really not efficient, I admit. Okay. And I get errors. Undefined variable vector rotate est. Where is that? Should be okay. Okay. And last of all, let's push the variable I made vex to vex per attribute, also and indexes as well. Okay. And if I get it correctly, not sure. I am not sure. Let's see. Somehow kind of worried that most of the vector A is giving me 0 value here. It's a bit weird. And I'm afraid I did something wrong here. Let's see. Okay, so that should be the first vector. So this is around here. So let's go through it. Angle, different length, scale. That. Let's see if I get this scale correctly. Okay, that's the reason. If I go to control, yeah, I gotta set some number here. Let's set the minimum and maximum to 0 to 100. And let's set the default value to 10. Let's go back to solver and go through again. Okay. And if I look at the vector, I get something weird. Huh. I don't seem to get anything. It becomes all 0. And why is that? Now, first of all, I don't need this one. Let's go back again and okay, now I get this. It's a bit weird, but it happens in solvers. Okay. Now this seems correct. So I'll apply it. Oh. Now it become 0 again. Wonder why. If I go back here, I have values, so should be okay, I think. Yeah. Should be okay. No. And next thing I will have to do, now that I have the indexes and the vectors for each primitive set, now I need to make a primitive or points. I guess I should make a points and transfer some attributes that I made before. So let's make a point wrangle. And since I want to make from scratch, oops, I'll input this to the second input. And let's name it move points to use those vectors to move the points and have the primitive set to the third point. Now, so the vector I have here is, how do I say, it's a vector to use for offsetting each points on the triangle, which is the result of the rotated value. And this will be done for each primitive set, and if you combine all together, that should be a total optimization for the mesh. And to make it understandable, I want to make this plural, just name wise. And let's go to the bottom and let's name it Vex. Okay. And let's go back and come again. I have values. Okay, let's start writing the fun part. Not really fun, but important part to move the points. Now first, let's get the indexes that I just made inside a primitive set. As a empty array for now, and let's make an array for position as well. And look through each primitive points. I mean the original mesh points. And get the position of the point. And add this position to this triangle. And append indexes, the point index, and append positions, the point position. Now for each point set, primitive set, get the temporal indexes that I made before, which is inside the indexes attribute at the I position. Also temporal vectors. Which is stored in the vex attribute, and for each make a temporal index and get the temporal vector. And also get the current positions using the t index, and get the, let's have the new position equal current pos plus tvec, which is the offset vector, and update the position and position vector in the positions array to a new position. And finally set point at rev. Oops. Set point at rev to geo self point the index new position. Apply, and I don't see no updates, which is not what I expected. Should gives me some point. And where did I miss it? Let's go through. Ah. Why I'm not getting anything here? So this is original mesh. Let's come to the third one, and the info is the second one. The first one here. And if I look at it, now it came. So weird. But still, I don't get anything. Right. So I have the point position. Where did I miss it? So indexes, array, positions, array, endpoints. Let me print this out and see if I get the thing I should get. Huh. It's not giving me anything. Is it because I cannot print it inside? Is that? Huh. I am not getting anything. Okay. Since I don't have any points or primitives here, that's why. But then, so I guess this is not cold. How about this? Do I get anything? Do I get anything? No, I don't. Well, let's add point. Wait a minute. This doesn't also give anything. Why is that? Oops. I always do this. I have to do this detail. Okay, now it gives me. But if I... Does it... Still doesn't give me anything. Set point attriv. Yourself. Sample. Samp. endpoints 2. So somehow I'm not getting, since this is empty. What's empty all the time? I don't get it. Let's go back again. Come back again. Now I have it. So weird. Okay, so I don't need this. So I'll delete this here. Do I get it? Do I still get it? Yeah. Luckily I do. Now I have points. The offset points. Now this offset point might not be on top of the geometry, so the next thing I should do is to use the ray to project the points on top of the original mesh. Use points, minimum distance, and here. This is the original mesh, and it'll be projected. And finally, I wanna change the point position of the original mesh here. Let's give a null between. And I think I need to use primitive wrangle, or no, point wrangle, I think. Yeah, point wrangle, since I want to go through each point. And first connect this mesh to the first input. Yeah, that's better. And the point position to the second input. The new point position to the second input. Now, let's get the new position from the second input. And apply this point to the original mesh point position. Looks a bit weird. It is changing, but in a weird way. Maybe the speed is too high. Maybe not. Okay, I must have mistaken some part. I have this here, I have this here, and offset is somehow really strong. Now, let's go back and see where I did it wrong. If I look at the vectors, for offset point. Doesn't look that wrong, but whoa, wow. It's obviously not correct. Okay. Well, I could have messed up anywhere inside here. That's the problem. It's really hard to debug. Let's see. Let's pause. Let me pause a little bit and look into the problem. Okay, I went through the code and I found one mistake, which was in optimization node, and that is somewhere on the last here. When I calculated for vect to rotate ST, I didn't need this edge length -1 by this, and if I go back, there's no more weird distortion. Now if I move the timeline, I see some point movement happening. Now in order to see if I'm getting the right optimization, I already made this circle, inner circles on the triangle, so I can see that if the point is going the correct way to get these circles packed. Now let's play. Now slowly I could see that point is moving. But it's so slow. I want to make it faster. So, in order to do that, I can go back to the controller and make it, yeah, was 1. So I can make it to 10, which will make it 10 times faster. And let's go back to the circle and play again. Yeah, now I can see it's optimizing quite fast. And let's keep optimizing. Let's just make the speed 200 since I am impatient. Okay. Now let's go. Yeah. Now it's really fast. Now it's optimizing quite fast. I do see some weird artifacts here. Not sure what it is. Maybe it was too fast. But it's kind of messy from the start point. I am not sure why is that. From here. Okay, maybe 100 was too fast. 10, yeah, 10 is good. So, well, I can just cheat and make skip to 240 and it will start calculate. And now you see the result. Yeah, and if I set to something like 1000, I see more optimized mesh. take some time to iterate all the frames. And here we go. Optimized CP mesh. Made all in VEX code. Well, finally, let's make some animation. Let's make it 10 is good, I think. Save this and do a flip book. Yeah, somewhere around here. Accept. Let's pull. Wow, it took like 2 hours to make this definition. This time it was too much coding, I think. I want to make something simpler next time. Now the hardest thing this time is to read through the papers. What could actually be done with vector operations? And I had to try and error a lot of times in order to find the optimized way to iterate through each points, through each triangles. Okay, and let's see. Yep. Cool. So this mesh could be used for something like 3D printing or architectural facades, structures, shells, or anything, you name it. Okay, thank you.